Hello.
Hello.
Yeah. Can you hear me?
Yes.
So today be doing some problems which are slightly different. They are going to be problems based on number basis, which is quite common in your AMCs. So first question is this one. Let n be a positive integer. Let n be a positive integer and d be a digit. D be a digit such that the value of the number C2D in base n equals 263 and the value of 324 in base n equals 11D1 in base 6. You have to find n plus t. So you need to know how to convert from one base to the other and so on. And you should be able to get some equations to solve for n and d.
Okay.
You will get a couple of equations here, right?
Right.
You should get these two equations. Are you getting these two?
Yeah, I got those.
So obviously, if you simply subtract these two equations, you will get d minus 4 is equal to 10 minus 60,
Yeah.
which immediately gets you d because you'll get 7d is 14, so d is 2.
Yes.
Once you get d is 2, you can solve for n from here. Get 3n square plus 2n minus 261 is 0. And this is divisible by 3. It is 3 into 87, I think. Yeah. So 9 into 29. And okay, so you have to think of, you can use the direct formula to do it also. This is 784. 784, I think, is 28 square. So this is, yeah, it is 28 square. So it's minus 1 plus minus 28 by 3. And you will
Hmm.
get n is equal to 27 by 3, 9.
Yeah.
This is a very simple question. You just have to get two equations and solve for n and d.
Right.
Are you getting this?
Yes, I got it.
So answer is n plus d is equal to 11. Okay.
Yes.
The second question is the number nb is the number such that is the number such that when it is written in base b, it is 123. What is the smallest b? What is the smallest b such that nb is the cube of a positive integer? So to find the base which is smallest base such that it is cube of a positive integer.
Right.
Are you getting anything?
Like, I wrote that since NB is like written in base B, it's 123. So then N is equal to B squared plus 2B plus 3.
B square plus 2b plus 3. This is in base 10 now.
Yeah. And now we have to make B squared plus 2B plus 3 a cube.
And you have to select the value of b so that it's the smallest value.
Yeah.
First of all, you should realize that when NB was written in base B, this is in base B. So what is the minimum value of the base when you look at this number?
3.
No, you cannot use the digit 3 in base 3.
Oh, right. So 4.
So minimum value of B must be 4, or it could
Yeah.
be 5 or 6 or something. If B is 4 and you check the value of this now, what is it coming?
8, 16 to 24, 27.
It's
Which
already
is
a cube.
oh, okay.
So the answer is 4.
Right.
The base could be anything higher than 4 also, but you've already gotten a cube in the lowest case.
Yes.
So that is your answer. We have to realize that if you're using the digits 1, 2, 3 in base B, the base cannot be 3, has to be 4 at least,
Right.
right?
Yeah, yeah.
Okay, so you just check the lowest value, it comes. So that's the answer. Otherwise, in general, it is slightly more difficult to think of like how can it become a cube.
Yeah.
So that would be a little more difficult because you will have to figure out how can we make this happen. So
Right.
in general, the solution will be harder, but in this case, it is very easy. Do you understand?
Yes.
Okay. Next question is a rational number written in base 8 written in base 8 is AB dot CD, where all the digits are non-zero, where all digits are non-zero. The same number in base 12 is BB.PA. BB.PA. Find the base 10 number. Find the base 10 number ABC. What are you trying here?
So I'm just writing out the equation. So like for AB point BC, AB point CD, I got like 8A plus B plus C over 8 plus D over 64
Hmm.
for
See,
that one.
when you want to equate two numbers, if they are equal, you don't have to equate the whole thing equal to the whole thing, because more information you will get if you say their integer parts are equal. And then you can say their fractional parts are equal, right?
Yeah.
So what I'm saying is, don't equate the whole thing equals to the whole thing. You can write two separate equations saying their integer parts are equal and their fractional parts are equal. Do you understand?
Yeah, so you're saying like 8A plus B would be equal to like 13B.
Hmm.
Okay.
That gives you more information than writing it and as a one single equation with C and D and everything.
Yeah.
You can later say also that C over 8 plus D over 64 must be equal to B over 12 plus A over 144.
Right.
But this already gives you good information. From here, you can say that 2A is equal to 3B. And
Right.
basically, A is equal to 3B over 2.
Yes.
If I put A is equal to 3B over 2, or let's just keep it as 2A is equal to 3B, because these are supposed to be integers and A and B are in base 8. So both A and B are less than 7. Right?
Right.
So there are only few options then, right?
Yes.
You can get A is 3, B is 2. That is one option. You can get A is 6, B is 4, right?
Yes.
You cannot get anything higher because A and B were written in base 8. They have to be smaller than 7 or equal to 7. Correct?
Yes.
So these are the only two options that satisfy this condition. And now we'll check these options directly in these equations, right?
Yeah.
So let's put A is 3, B is 2, and then see whether it is making any sense for the second equation. So B is 2, so 2 by 12 plus 3 by 144. So this becomes 1 by 48. This becomes 1 by 6. So you're getting 8 by 48, 9 by 48, which is basically 3 by 16. So right hand side is becoming 3 by 16. And that here it is 8C plus D by 64, right?
Yeah.
If you cancel, say 4, so 8C plus D is equal to 12, right?
Right.
Now you have to realize again, C and D are also digits which are less than equal to 7, because C and D were also written in base 8, right?
Yeah.
So how can you get 8C plus D equals 12? C can be 0 also, but then D is not possible. So C can has to be 1, right? If you
Yeah.
put C as 1, D is 4. C is 1, then D is 4. If C is 2, it's impossible. So this is the only possibility, right?
Right.
Do you understand what I'm saying?
Yes, I understand.
So we are getting A is 3, B is 2, then C is 1 and D is 4, right?
Yeah.
Similarly, you can also check the other case where A is 6, B is 4, correct?
Mm-hmm. Yeah.
So one of the numbers that we are getting is, let's put one of the cases that we are getting, ABC is 3, 2, 1, right?
Right.
The other case is when A is 6, B is 4. If you put that here, you'll get 6 by 144. So 24 plus B is 4, so 1 by 3. So this is 8 by 24, 9 by 24. So that is 3 by 8. 3 by 8 is coming on this side, and this is equal to 8C plus D by 64. You're getting 8C plus D by 64 is 3 by 8. So 8C plus D is equal to 24 in this case. And 8C plus D is 24. So now we check again. C cannot be 0. C cannot be 1 also, because D will be too big, 16. If C is 2, D is 8, right? But 8 cannot be used because it is base 8, right?
Right. Yeah.
And if C is 3, D is 0, right? That's fine. So C is 3 and D is 0, correct?
Correct.
Then you're getting 6, 4, 3, 0. And now is it matching both the situations? The numbers are 64.3, and this number is what? This is in base 8, and this number is BB. So 44.46 in base 12, right?
Right.
And ABC is coming for us as 643 in base 10, right?
Right. Yeah.
Uh, One second. The answer is saying that the second part has no solution. So we have made some mistake. C plus 8D is 24, has no solution, you're saying.
C plus 8D is
So why
24.
are you saying C plus 8D? It is 8C plus D, right?
Yeah. So then C is 3, and then, yeah.
1 second. C by 8 plus D by 64 is D by 12 plus A by 1. It is 8C plus D. I think 8C plus D has a solution. So we can easily say that C is 3 and D is 0. There is no issue with that.
Yeah.
So I feel like the answer is wrong. There are two solutions possible. We have gotten the two cases.
Right. Yeah.
But do you understand what are the things to keep in mind?
Yes, I understand.
First of all, like if we directly write the whole number as one equation, it might not be that useful. When you are
Right.
equating two numbers which are decimal numbers or rational numbers, it is better to do the real integer part first and then the fractional part.
Yeah.
Then you have to keep in mind always that whenever you get equations like this, because there is a restriction on the highest digit, it has only a few options. Here it was base 8, so both A, B, C, D, everything is smaller than 8.
Right.
So then you can just list down the two cases that are possible.
Yes.
Similarly, like once you have listed down those cases, then the second equation becomes easy to solve because again C and D have to follow such restrictions. So if 8C plus D is 12, you have only one possibility of 1 and 4, right?
Yeah. Right.
So that is how we solve the problem. Uh, okay, next one is another AMC problem. Question 4. It says basically hexadecimal or base 16 numbers. They are written by using the digits 0, 1, 2 till 9. So this is 10 digits. And after that, you will use the letters A, B, C till F. These are 6 letters. What do those letters mean? This letter stands for the number 10. This letter stands for 11,
Yeah. Mhm.
12, and so on. 10, 11, 12, 13, 14, 15, right?
Yeah.
So basically, these are the things that you'll be using. You cannot use directly 10 because that will take 2 digits, right?
Right.
You'll use A, B, C, D, E, F to stand for 10, 11, 12, 15.
Yeah.
Now, among the first 1,000 positive integers, there are n whose hexadecimal hexadecimal representation representation contains only numeric digits. Basically, representation does not have letters. What is the sum of these n? Sum of the digits of n. Oh, okay. Sum of the digits of n. So first of all, you have to count how many hexadecimal numbers you can make which will not use any letters. Once you have counted that, you have to find that is your n, find the sum of the digits of n.
Right. Would the answer be 9?
How many such numbers are you getting?
153.
Why? How?
Because um because 99 would be the last like base 16 you could write without any letters, and 99 is 153 in base 10.
What are you talking about? 99.
Like 99 base 16.
You have to look among the first 1,000, not the first 100.
Yeah, so then but then all the rest of the first 1,000 positive integers have in hexadecimal have letters in them.
No, they don't.
But then 154 in base 10 has 9 and then an A.
154 in base 10.
I mean in base 16. 154 in base 10 in base 16 is written as 9A. So it has a letter.
You are wrong. Think again. There are many more numbers that are possible which don't use letters. Many more than 99.
No, I got 153 as my answer.
The answer is much more than that. There are many more letters, many more numbers that use just 0 to 9 in base 16. You can make 3-digit numbers. You don't have to restrict yourself to 2-digit numbers. What is 1000 in base 60?
In base 60?
In base 16.
Oh, 1000 in base 16. Mm, 4096.
That doesn't make any sense. How can it have bigger digits than base 10 number 1000?
Oh, wait. Never mind. I'm confusing the conversion. Hold up. 1000 in base 16. 1000 is 3E8.
If you want to make a number smaller than 1000, you in base 16, what are the options for the first digit and second digit and third digit? You don't want to use letters and you want it to be smaller than this number in base 16.
So 398.
How many options are there for the first digit here?
Oh, 3.
No,
1,
there are four
1,
options. You
1,
could put
2,
a
3.
zero also.
But then it wouldn't be a 3 digit.
Is two digit it will be smaller or bigger?
Oh, okay. So then 4.
What are the options for the second digit?
10.
And how many for this digit?
Uh, 8.
No, 10.
Oh, right. Since your second digit is smaller. Okay, yeah, 10. So 400.
This includes one case where all are zero, which is not going to be positive. This includes one case where all digits are zero. We are excluding that case. There are
Yeah,
399 numbers that you can make, which are either three digits or two digits or one digit in base 16, which don't use any letters.
right.
They are all smaller than 1000.
Yeah,
In order to make the answer the question that you have to make digits smaller than 1000, the first step is to convert 1000 to base 16.
right.
You cannot do the question randomly without even knowing what 1000 looks like.
Yeah.
The answer for required number of numbers is 399 and sum of the digits is 21.
Yes.
A positive integer n has base 11 representation ABC and base 8 representation 1 BCA, where ABC represent not necessarily distinct digits. Find the least such n. Find the least such n expressed in base 10. What equation are you getting?
I did that. The base 11 representation is 121A plus 11B plus C, and then the base 8 representation is 512 plus 64B plus 8C plus A, and then I equaled those, so I got 120A minus 53B minus 7C is 512, and then we know that A has to be less than 8 because it's like written in base 8. So, and then we also know that A has to be greater than 500. 120A has to be greater than 512 because you have that 120A minus 53B minus 7C.
From this equation, now what all can we say? We know ABC is less than equal to 7, right?
Right.
So then what can we say now?
Um, I did it like 128 minus 53b minus 7c is equal to 512. And then we know that 120a has to be greater than 512. So then a has to be greater than like 4. So then you get that a can be 5, 6, and 7.
Okay. So if it is 5, what is happening?
Wait, I have to do that part.
Very easy. Why is it taking so long now?
Oh
It
yeah,
will,
so if a is 5, then you'll just plug it in and then you get 53b plus 7c is 88. So then you get b is 1 and c is 5. So then you have that triplet 5, 1, 5. And then if a is 6, you get like you just do the same thing. And then you get that b is 3 and c is 7. And then if A is 7, you just do like the exact same thing. So then you get B is
What is the
5.
answer? Least such n.
So then the least such n would be 621.
How is the least such n 621 when you have already got an answer 515?
Because if you plug in the 515,
The least number out of all the numbers is 515 or 621?
621.
In what
Because
way
you
you
plug
want?
because so you have A is 5, B is 1, and then C is 5, right? So then you plug in A is 5 to 121A, B is 1 to 11B, and then C is 5 to C to get your N. And if A is 6, it'll be something even greater, so we can't use that one.
The smaller number will be 515 or the smaller number will be 621?
Wait, I thought we're finding the base 10 representation.
In which representation, in any base representation, can 621 be smaller than 515?
No.
What are you talking about, dude? Least such number will be 515 or 621 in whatever base you want.
5
How can
1.
621 be smaller than 515?
No, I was saying like 621 is the base 10 representation.
What is the question asking you?
Find the least n expressed in base 10.
So how is it 621?
Because it's saying that the base 11 representation is ABC. So then we convert the ABC in base 11 to base 10 to find that n.
You are saying that you are converting 515 to base 10.
Yeah.
Okay, that is correct. 515 in base 11 can be converted to whatever.
Yeah, that's what I was saying.
Fine. That's the answer then. Okay. Write down this question. You have to try that for the next class. You have to find the three greatest numbers less than 1000 in base 10, which are palindromes in both base 10 and base 5. And you have to find the sum of those three numbers.
Okay.
Find this answer. The next class will be we'll be doing a different topic. We'll be going ahead with the theory for number theory.
Okay.
Okay.
Uh, yeah, I copied it down.
Fine. That's all for now then.
All right, thank you.
Bye.